All right, in this video, we're going to find the inverse of a matrix, specifically a 2 by 2 matrix, and we're going to do that with the augmented matrix method with I, which is the identity matrix. Okay, so before we get into that, I want to show you some rules right here, and those are these row operation rules. Okay, so here in a minute, these are the three rules we are going to use. We can switch any two rows, we can multiply any row or two rows by a constant that is not equal to 0, or I can add rows together. Okay, so we're going to use these three rules to manipulate my equation here in a minute. Okay, so the first thing I'm going to do is I'm going to set up the augmented matrix with I. I is the identity matrix, which has ones going diagonal from left to right and zeros in the other spots. So if I create an augmented matrix, so since I had an original 2 by 2, I'm going to use the 2 by 2 identity matrix, which you can see here has the ones diagonal and then zeros everywhere else. Okay, now the goal is to manipulate the left side of the equation with these rules right here. Okay, and I want to create the identity matrix on the left side. Now as I do that, the right side is going to change along the way. So whatever I do to the 2 to the 7, I also have to do the 1 and the 0. Same thing for the 1 and 5, I have to do to the 0 and 1. All right, and then at the very end, I'm going to have a matrix that looks like this. You're going to have 1, 0, 0, 1, and along the way, all these numbers will have changed to something different, and that's going to be the matrix we're looking for at the end. Okay, so very first thing is I'm going to see if I can take these two rows and I just switch them. Okay, I'm going to flip-flop them because that 1 is right there, and I want the 1 in the top right-hand corner. All right, so if I just flip them, I get 1, 5, 0, 1. 2710, right? I've just flipped them. All right, so now I have 1 in the right spot. All right, now a good rule of thumb is I want to start by getting all the zeros in the first column first, then go get the 0 in the second column. By doing this, it's going to make it a lot simpler. You're not going to have to backtrack as you go through this. All right, so if I take the first row, multiply by -2, what you end up getting is, so if I say -2, I have -2 minus 10, 0, and -2, right? That's my new first row. Now, if I take that and I add it to that row, right? So then I would say 2, 7, 1, 0, and add those together, right? So what I have now for my new bottom row would be that -2 plus 2 is 0. -10 plus 7 is -3. 0 plus 1 is 1. 0 plus -2 is -2. All right. Now then, I'm going to keep the first row the same because I don't want to change that one, right? So if I could just take this row right here and just multiply by 1/2 again, I'm going to get that row right there, right? And so I can multiply by a constant that's not 0, right? If I take this and multiply all of that by 1/2, I end up getting this row right here. All right, so now I got a 1 and 0 set in the first column. Now I'm going to go work on the second one right here. Now, think of this in terms of elimination method for solving a system, right? If I multiply the top row by 3 and the bottom row by 5, what you'll end up getting is 15 for both of those spots, at which point that can eliminate, okay? Now, some people might say if we multiply by -1/3 right here, we'll end up getting a 1 in that spot right here, but what you also get is a fraction over there. So if I deal with the zeros first and then go back and try to get the ones, delay using fractions as long as possible, right? So if I take the first row, multiply it by 3, you're going to get 3, 15, 0, and 3. Multiply the second row by 5, I'm going to get 0, -15, 5, and -10. All right, then I'm going to go through and create a new matrix, right? I'm going to leave the bottom one the same because that's not the one I want to change. All right. Now I'm going to add these two rows together right here. So 0 and 3, 15 and -15, 0 and 5, and 3 and -10. All right, so that's going to give me 3 on the top row, 0, 5, and -7. Okay, so now if you'll notice, I'm getting real close, right? I have all the zeros in the right spot, but the only thing I have is I got 3's here and here. So if you multiply by a 1/3 to each row, right? So the first number becomes 1, second number is 0, then I've got 5/3, I have -7/3, And if I multiply the bottom row by negative 1/3, I get 0, 1, negative 1/3, and positive 2/3. Okay? So now I have successfully taken my matrix, my original matrix, set up the augmented matrix with the identity matrix. Then I've used my row operations for all of these steps here. And then now my left side looks like the identity matrix from the beginning. And this is the new matrix that I want right here. So this part right here is going to be my inverse. If I come back to the top and I say a inverse is going to be 5/3, negative 7/3, negative 1/3, and 2/3. Okay? And so that is how you find your inverse, is using augmented matrix with the identity matrix. Now, one more thing I do want to point out. If you take A times A inverse, okay, this is a way to check yourself, and you will get the identity matrix, right? So what I'm going to end up getting is 1, 0, 0, 1. If I take these two matrices and multiply them together, I get that identity matrix, okay? So real quick way to check yourself. That way, if you get to the end, there's a lot of steps right here. So to check it without going through all that work, just multiply the original times the new matrix to see if you get this identity matrix. And if you do, you know you're in good shape, okay? All right. Hope this video helps. And in the next one, I'm going to show you how to do this with a 3x3.